In this little video, we're going to take a look at factoring trinomials, typically whose leading coefficients are not 1. And I have an example, a concrete example there underneath the general form. Now this general form, if you take a look at a few things, can kind of provide you with some hints as to how you might go about it. For example, you multiply the fronts to get the fronts. You multiply the backs to get the back. But if you take a look at it, you also have a mixed factor here in the middle, as well as another mixed factor. And so it kind of gives you a hint as to what to do, and it's maybe just factor the front number and the back number, and go ahead and combine them through some form of addition. Now, there are things that you can do to minimize the guesswork. Ultimately, though, this is kind of a trial and error sort of method, but I find that it's actually a little faster than grouping, mostly because you got to go through the same steps, but this just sets it up for you. So let's go ahead and get started. First things first, we need to learn to read the signs. If we don't learn to read the signs, we have to ask ourselves different questions, and those questions become a little bit more difficult to answer. And so if we just learn about the signs first, I think it'll be very, very helpful. So the only way to get this back sign here is to multiply those two back numbers. So if the signs of the factors here are the same, when you multiply them, you're going to get a positive answer. When they're different, you're going to get a negative answer. So having a positive back here says that the signs of our factors are the same. So the signs of the factors are the same. It doesn't tell us what the factor signs are, it just tells us that they are the same. One other thing that it does, though, is it does tell us something about this middle term here. And that is that if I want to combine these, they will have the same sign. The assumption there is that A and C are both positive. If A and C are not both positive, I would factor out a negative to make the positive. It will make your job a heck of a lot easier down the road. Plus, it'll make these sign rules kind of make more sense. So with A and C positive, if B and D are the same sign, then they will add in order to combine themselves to make that middle term. So this sign also says that you add those two. So you add the factors, or I'm going to call them mixed pairs. Now, this middle sign here, this negative, is the sign of your larger pair. And it's the reason it's the sign of the larger pair is however you combine AD and BC, those two things that combine to make that linear term, in our case 11, the sign of the larger one is going to dominate the smaller one. And so this tells you right away, if you have a dominant pair as far as one is larger, then it must take that sign. That's how it combines. So the good news is we can take these two signs here and make a very good take a very good look as to what this might be at the end of all of our steps here. And since they're the same and the larger one is negative, they must both be negative. So we should come up with an answer that looks like this. Some number times x minus some number. And that should happen in both. Now we just need to know what those numbers are. And that's what we're going to do in steps 2, 3, and 4. Okay, so let's go ahead and get started. The very first thing I want to do is rewrite this so I've got a little something to look at while I'm scrolling down. Alright, so we want to factor the front and the back separately. So let's go ahead and take the 6, and now you want to write the factor pairs of 6. I always try to start with 1 because a lot of people tend to forget 1. And so I'll start at 1 and say 1 times 6 is, or 1 times what is 6? 6. 2, does 2 work? Yes, is 3. If I continued on and ask those questions to myself. And on the back end, 4 is also 1 and 4, and 2 and 2. Now that we have those factored out, and by the way, those numbers can be quite a beast to factor if they're rather large, or in the case of 72, it's not that large, but there's a lot of factor pairs of 72. So we want to go ahead and try to find the pairing that works the best. Now, when I do this on my own, or I'm teaching it live, and I don't have my webcam on right now, so you can't watch me doing this, but I'll actually place a finger on the two factors that I'm multiplying, just to say take this times this. Okay, now take these two things multiplied, and I'll move my fingers just to kind of keep them straight in my head. I'm going to do the exact same thing though here, but I'm going to do it with colors. So I'm going to go ahead and circle the ones that I want. So I'll take 1 times 1. That gives me 1. And then I'm going to take 6 times 4, and that gives me 24. And according to my second sign, I go ahead and I add those to make 25. And the question is, does it equal negative, or does it equal 11? I don't really need the negative because I've got the signs took care of that. It doesn't, so we got to start over. All right, so last time I went 1 and 1, so now I'm going to go 1 and 4, and then I'm going to go 6 and 1. And so 1 and 4 is 4, 6 and 1 is 6, and if I add them together I get 10, which is close, but it's not quite 11. Okay, so we'll go ahead and we'll start over there. Now that I've checked 1 and 6 with 1 and 4, I'm going to stick with 1 and 6, and I'm going to go to 2 and 2 on the 4. So I'm going to say 1 and 2 is 2, and then 6 and 2 is 12, and I'm going to add them together to give 14, and that is not 11. So I have that problem. Now, because the factors here of 4 are the same, just simply reversing the order is going to give me the same answer. So in other words, I have looked at all the possibilities of 1 and 6 and nothing works. So I'm going to go ahead and cross those out now because I can't use them. Now I go on to 2 and 3 and I check that against 1 and 4. So 2 and 1 is 2. 3 and 4 is 12. If I add those together, I get 14, which again is not what I'm looking for. So I'm going to go ahead and try 2 and 4 this time. That gives me 8. And then I'm going to try 3 and 1. That gives me 3. And if I add them together, I get 11, which is what I'm looking for. So the good news is my pairing is 2, 3, and 1, 4. Those are the factors of the numbers. All right, so now I know the factors of the numbers. Now what do I do? All right, well, I'm going to go ahead and write these back down. And now, as I'm writing them down, so I have 2, 3, and then I have 1, 4. Oh, come on. 1 and 4. I want to go ahead and kind of keep in mind that I'm looking for something in this form. AX plus B and CX plus D. Okay, so now I have to remember what I matched up with what. So I matched up, according to my colors here, I matched up 2 and 4. So I'm going to go ahead and circle 2 and 4, and then I'm going to underline 1 and 3 so that I know that those pairs must work together. So now I can go ahead and just insert those. Since it works, it must be of the form AX plus B times quantity CX plus D. And all I got to do is put in the numbers. Well, these two numbers are in the front, so I just go ahead and I set this up now. I'll put that 2x in the front. I'll put that 3x in the back or in the front of the other one. And now I take a look at my signs. In my case, or in this case, we have two negatives. We went through read our signs, and we found out that we need both negatives. So I'm going to go ahead and plug those negatives in now. Here come the tricky parts. All right, now, who goes with the 3? The 1 does. Since the 1 goes with the 3, it does not stay in that factor, but must be in the other factor. That's the only way it's going to multiply. If you're watching this and you haven't taken my course, I tend to be just a little bit, not paranoid, but unreasonable when it comes to a certain dirty 4-letter F word. And my students, if you're watching this video, this does not count towards your pizza party. All right, so let me explain. A lot of people, when they see two binomials, have been taught or prefer to do something called FOIL. Now, it should be said that FOIL is not a thing to be doed. Okay, it is. You don't do FOIL. FOIL is simply a mnemonic device that tries to help you remember how to expand two binomials into a trinomial. That is all it does. What you are actually doing is performing the distributive property. That's what it is. So FOIL is this 4-letter F word, and I call it the dirty 4-letter F word because I found out that if I teach it to my students, they try to use it in situations where they can't, and then they get frustrated and they take it out on the book or the program or their homework, and so I just stopped teaching it altogether. But it stands for first, outside, outside, inside, and last. It's the distributed property. That's all it is. And so I don't really go about teaching it. However, it is at least almost sort of possibly handy here. Maybe. I'm not going to go so far as to say that I'll permit it in this particular instance, but it can help. Now, when you're multiplying, you never multiply the two factors within the same, or the two terms within the same factor. So if you have to multiply 1 and 3, then they have to be in different factors. That's simply where I might say it could possibly be okay to use that dirty 4-letter F word. All right, so now I have the 2 and the 4. They also must be an opposite. And so, because they have to be able to multiply, and so here's the setup. Now, if you go through this problem and you get 3x minus 4, that quantity times the quantity 2x minus 1, it doesn't change anything. You can reverse the order of multiplication, and it doesn't matter. All right, well that's it. That's kind of the way that that a student of mine brought it up to me and said, well, this is the way I learned it in high school. That's great. A different way. When I learned it in high school, it was try it until it works. If you can't find something, it might not be factorable. This is at least a little better.